cage-type zeolites such as DDR, LTA, and chabazite find applications in membrane pervaporation of water alcohol mixtures. In my talk today, I'm going to describe a phenomena which I term mutual slowing down that is experienced for water methanol and water ethanol mixtures as they diffuse within the cage window structures of DDR, chabazite, and LTA. This mutual slowing down is caused due to hydrogen bonding between the water and alcohols. The material I will present is based on two papers of mine, both published in 2010. One in Langmuir, the other one in Journal of Physical Chemistry C. For background details on the structures of DDR, LTA, and chabazite zeolite, I invite you to watch my presentation, Diffusion and Cage-type Zeolites, on my YouTube channel. For diffusion of water in LTA, there's strong hydrogen bonding between pairs of water molecules that has the net effect of reducing the mobility of water, and the intercage motion of water molecules is severely retarded due to molecular clustering. This is qualitatively explained by this animation, where you get a feel for the molecular clustering phenomena. Molecular clustering also occurs for pairs of methanol molecules. For water methanol mixtures, there is significant hydrogen bonding between water molecules and water methanol molecules. The bonding between water methanol molecule pairs leads to the phenomena called mutual slowing down. Let's first have a look at the animations here. The green molecules are water. The phenomena of mutual slowing down is quantified in this diagram, which plots the self-diffusivity of water, shown by the blue triangles, and methanol as a function of the mole fraction of water in the adsorbed phase, where the total pore concentration of the mixture is kept at the value of 50 molecules per unit cell. with increasing water loading, the methanol self-diffusivity undergoes a reduction. Also, concomitantly, the diffusivity of water is reduced with increased concentration of methanol in the mixture. Both components undergo slowing down effects. Let's examine the influence of molecular clustering on diffusion in DDR zeolite. We first have a look at the animations for water diffusion in DDR. There's some visual evidence of clustering between pairs of water molecules. There's also some clustering between pairs of methanol molecules and pairs of ethanol molecules, as evidenced here. This graph shows MD data for the self-diffusivities of water, indicated by the blue triangles, and methanol, indicated by the yellow diamonds, in DDR zeolite. Due to hydrogen bonding between water and methanol, we have mutual slowing down of water and methanol. For example, the diffusivity of methanol is reduced by 1 order of magnitude with increased proportion of water in the adsorbed phase. Concomitantly, the self-diffusivity of water is reduced with increasing proportion of methanol in the adsorbed phase. Let's examine molecular clustering effects in chabazite. These animations are for methanol-ethanol mixtures, and there's some visual evidence of molecular cluster formation, albeit qualitative in nature. This graph presents MD data for self-diffusivities in water-methanol mixtures in chabazite. The total loading of the mixture is held constant at 2 molecules per kg, and the self-diffusivities of water and methanol are plotted against the mole fraction of water in the adsorbed phase. We note here the data for self-diffusivities of methanol, indicated by the yellow diamonds, that the self-diffusivity of methanol is reduced due to increased proportion of water in the adsorbed phase. At the same time, the self-diffusibility of water is reduced due to increased proportion of methanol in the adsorbed phase.